Hello everyone, this is Linda Namanja Patricia, pursuing a bachelor's degree in software engineering. So I'm going to take through about the facial expression technology. Yeah, I found it very relevant to introduce something like that. So it's artificial intelligence. So the problem definition I have for you is facial recognition. So facial recognition will be this system capable of matching human faces against the database of all faces in the most people. Then the intention of this is to reduce the numerous touch points and even for security purposes. Then this system will be like, the reason why I came up with it, to be able to be working in different departments. So why did I choose this? It was to monitor large groups of people so that we aid the security risks, because we see that many crimes are being done. They only take fingerprints, then thumbprints. But for my case, I wanted to bring out the facial recognition technology. So, and also the main goal was to reduce the number of touch points in the community, because we've seen all diseases like COVID, Ebola, they're trending now. They were trending, but because of those contact points. So the reason I brought up this is to overcome that. Then someone may ask him also, how will it be applied? So using this AI, because it's so good, it's very vital in our community. It will be able to analyze the facial expressions in terms of images and then videos, so that the machine can pick up all that information according to one's gesture state. So in so doing, I chose to use deep learning in this aspect in order to identify that and interpret human expressions that it was saying. So those are emotional things, but if it comes to human expression on the face, yeah, I'll be recognizing the eyelids, then the nose, everything. Then which type of data will be required in this aspect of facial recognition technology? First of all, in the data set, there will be about face detection, then face aligning, that is the shaping of the face, then feature extraction, so that they can bring up that face who views the real you. Then it also requires visual data to be stored in the database of all kinds of people in order to capture recognitions quickly. And basing on the emotions, that was an example, but I'm going to face recognition, that is face detection, face aligning. Then we know that there are methodologies that we can use while I try to come up with this thing. Then it is supervised and then non-supervised. Let me tell you the differences about it. In supervised, they have available training data so that they can train the machine on what to do. But in non-supervised, it is unlabeled data. Then also in supervised learning, there is supervision needed while training the model. Whereas in unsupervised, it just finds, does not need supervision even. So in supervised learning, it predicts the outcome. For example, you can train the machine on different shapes. So it will be like the sides which are equal. It has 4 sides, but when they're equal, that's a square. Then when it's round, it's a circle. So the machine will be able to pick up all of those stuff, and it will predict that if I have something of 4 sides, what will I output? So it will be a circle. That's all about supervised learning. Then unsupervised, Unsupervised learning finds the hidden patterns in data. So those are the categories also. There's regression and classification. So if we go further into the techniques of supervised learning, we have regression and then classification. Classification is all about grouping the data into classes. For example, you can, if you are taking in the faces, you can identify according to the color. Some people are brown, black, even also chocolate, something like that. So it will be able to, the machine will be able to group those people into classes, the black people, then brown, and then chocolate. That's all about that classification. Then regression, it will just determine one is emotion status, and then it groups. For it, the label is continuous, whereas in that classification, it's discrete. Then under unsupervised techniques, we have clustering, which involves just to finding the similarities between the data objects. And then as per the presence and then absence of their commonalities. So it also aids the fetching of the unknown and hidden patterns. So anomaly detection also, it just identifies the abnormal behavior as compared to the established patterns. So anything that deviates from that established baseline is considered as an anomaly. Then if we go to technical challenges while coming up with this facial expression technology, there will be a problem of occlusion. Occlusion is like you expect something to output something in such a way, and it does it the other way around, which is due to some settings or like properties of the sensor of the technology. We also have infrastructure as a technical challenge. So for the case of getting detectors and sensors, it's very, very expensive. Then there's also low resolution. You can capture the image and it is just fade, which will bring about confusion into the machine. So there's also face detection, extraction. And that's all about those techniques. Those are the technical challenges that you may face while coming up with a facial recognition technology. So the possible solutions to solve these challenges is like you have to focus on the problems that really matters to overcome the problem of occlusion. Then also you have to sensitize the students doing such courses of artificial intelligence, having courses of this sort, to not take it for granted, because we know that the world keeps on moving and then the technologies are also advancing. So better to keep it in mind that those courses are really, really relevant. They enable you to think smart before you do anything else. And also, you have to take your time and choose the data set rightly, because it's the key in artificial intelligence. Let me think you're getting. Then among the terms used, we have accuracy, recall, and then precision, fun score. Accuracy, just the way how to measure how often the algorithm classifies data points correctly. Then recall just quantifies the number of correct possible predictions made out of all possible predictions that could have been made. Then precision determines how close the measurements of the same are to each other. Then F1 score, it is a combination of the two. That is precision and recall. It is used to measure the performance in binary classification. And we know that it's a model accuracy on the data set. Then under the facial recognition evaluation metrics, we'll have the accuracy. Accuracy just determines the ratio of the number of correct predictions to the total number of input samples. This is only that calculates the accuracy of your model. Then we have also logarithmic loss. It works by penalizing the false classifications. Then we have also confusion matrix, gives a matrix as output and determines the complete performance of the model. So that's all I had for facial recognition technology, because I found it very vital in our community. It could enhance the security risks, and then it could enhance security, and then also reduction in the touch points to overcome those outcome diseases that are already trending. But if we introduce this thing of facial expression technology, it will be of good, of help in our community. So we've seen the methodologies we used for this case in the facial expression technology, how require more of the deep learning technique. Reason being, it will identify and interpret human expressions by taking all that face detection, then face aligning, that's the shaping, all of that sort. So so for the case you're using supervised learning in facial expression technology, it tells us that you must be 95% accurate. So the machine must be able to capture your face the way it is, with your parts, the eyelashes, the way they are, so that it can pick it up clearly. Though it is the other side, it can pick it. That's how vital artificial intelligence is. So I found it very relevant to come up with facial recognition technology. Thanks for listening. It's been Linda Patricia. Okay.